Hey everyone, this is Teresa from Base 10 Montessori, and today I'm going to put all my stamp game videos together, and I thought I'd make one big video just in case you guys didn't want to link to all the different videos I put out. I'm going to put all of them together in this one. I'm going to give you a little bit of an introduction to the stamp game, and then I'll put all the videos that I've made together in this video so you can scroll through it to each different section, whether you want to do addition, subtraction, multiplication, short division, long division. All the videos will be right here in this one video. And also starting out, I want to give just a little bit of an introduction about the stamp game so that you have a little bit of background information before you jump into all those videos. I thought it might be helpful since I have like 6 videos that maybe this compilation would be useful for a few people. So we'll see. If not, let me know down below if this was a good idea or a bad idea. I thought I'd just try something different. So anyways, let's go into the introduction to the stamp game real quick. So what is the stamp game? If you haven't watched any of my videos so far, the stamp game is a math material originally developed by Maria Montessori, and originally it was used with stamps, so that's how it got its name. That's why we call it the stamp game. So anyways, it is a math material, and it's found in the decimal system of the AMI math album. It's used for static and dynamic operations for addition, subtraction, multiplication, and division. So in the decimal system of the AMI math album, we're really focusing on teaching the child what is a unit, what is a 10, what is 100, what is 1,000, and then we teach this to about at the age of 4. We start teaching that concept. And then we start also teaching operations with the golden beads in the decimal system. So once they understand what a unit, 10, 100, and 1,000 is, we can start doing addition, subtraction, multiplication, and division. And that's what they're working with around the age of 4. They're going to be working with that golden bead system to have a really, really concrete experience with the decimal system and operations. So when the child gets to the stamp game, they have already learned the place value for units, tens, hundreds, and thousands through the golden bead system, and they have been introduced to the operations in the golden bead system, all the operations, addition, subtraction, multiplication, and division, before working with the stamp game. And the purpose of the stamp game right here is to become a little bit more abstract, to use a slightly more abstract material when doing these operations in the decimal system. Who should use this material? So if you're using this in a classroom setting, if you're using this in a homeschool setting, the target age for introducing this, for my classroom anyways, is about a 5 to 6-year-old child who has already been introduced to those operations with the golden bead system. And so this isn't their first exposure to doing addition, subtraction, multiplication, and division. This would be a child that has already had some exposure to that, has some interest in that, right? And the purpose of the stamp game is to give the language for the parts of the operation. So for instance, for addition, it's going to be addend for both parts of the equation, and of course the sum. Or in subtraction, we have the minuend, subtrahend, and the difference. So if you don't know the parts of the operations, don't worry. In my videos, I cover all of that, so the language is there for you. And then we also introduced the symbol for the operation. So this is where we would introduce the symbol and the language for the parts of the operation. And of course, the purpose is to help the child understand operations, right, in a slightly more abstract context than the golden bead system. Because as a child learns, we want to start out very, very concrete and move towards more abstract until finally, when they're older, they can do everything in their head. Or if you're like me, it's really nice to have a calculator or a stamp game, but ideally we want the child to be working abstractly down the road, unless you're someone like me who is still stuck with calculators. I was a public school child. I wasn't a Montessori child. I wish I had this education when I was younger, but I'm making up for it now by becoming a Montessori teacher, right? Anyways, and the control of error. Let's talk about the control of error in this process, because I talk about the control of error a lot on this channel. And what I mean by control of error is, how does the child know that they did the work correctly? Is there a way for the child to know that he's done the work correctly without going to the adult or Do they have to go to some sort of chart to find out if they've done it right? And sometimes in the materials, we have a control of error that's in the material, but that is not the stamp game. The control of error for the stamp game is in the process. We are interested only in the process, not the result with this material for this age group. There is a different set of materials that we do a lot of control of error where the child has to find what the answer is in another piece of material. This is not it. This is not something that if the child comes to you, you're going to correct their work. Not at the age 5 to 6 and not with this material. When I get more into the memorization of math facts, there's control error, but the control of error in that in those math materials, but they're not control of error. There's not a control of error in the stamp game. So really, we just want the child to have the experience of doing operations in this context. And really, the way you approach mistakes is just through observation. Is the child starting to understand it? Do you observe the child doing the work correctly? And if you see that they're having trouble, and a lot of time the trouble comes from exchanging, make an observation about that, make a note. Maybe you have to represent it. Maybe the next time you present this lesson, you can present it to another child, a new child, and the other child can be kind of a helper or a watcher or an assistant. And they can kind of watch that lesson one more time. So those are the different ways you can help a child who's struggling with this and hasn't quite gotten it right, might be struggling with one aspect of it. So sometimes it just comes down to having the child slow down and organize their work. Sometimes that's why they're making a lot of mistakes with this work. But anyways, this isn't a material that we're really going to focus on pointing out the child's mistakes to them. Not that we do that very much in Montessori. We want the child to find their own mistakes and correct them. So that's a little bit of what I have for you on that one, but I have another picture I want to show you real quick. And this is my handy dandy chart right here that I like to keep around when I'm showing you the lesson sequence for all the lessons. And in the blue, we have all the math lessons in the AMI Montessori album. And as you can see, the stamp game, hopefully you can see the stamp game on there, kind of goes at a diagonal starting at 4.5 years old, just a little bit older than 4.5 years old. You're going to see addition, stamp game, subtraction, multiplication, and division. It kind of goes at a diagonal. And before that, we have the collective exercises. When we say collective exercises, that's the golden bead system. That's the very, very concrete, a very concrete presentation of the decimal system and the operations. So that's the most concrete it gets with that. And the stamp game is a little more abstract. So as the child is working on the stamp game, they're also really solidifying their linear and skip counting. We have bead chains that go all the way up to 1,000 beads. And they're also solidifying their teens and tens through the teens and tens boards. You might also know the teens and tens boards by a different name. We call them the Seigan boards. So after they get through the stamp game, as they're starting to really move through that work, they're going to start working on the next category. And if you look a bit to your right, you're going to see like the addition strip board, subtraction strip board, and so forth. That's where we're really going to focus on a control of error. That's where we're going to work on the memorization of math facts. And that's where we're going to make sure that the child goes, looks at their work and makes sure that they have the right answer. So that's a little bit about the stamp game and where it falls inside the classroom. Ideally, in the classroom, in the Montessori classroom, the stamp game is going to be around 5 years old, with the more advanced stamp game lessons, such as long division, would be closer to 5.5. A lot of my students don't get to long division in kindergarten. I only had, let me think. I've only had one student who did long division before they moved on to first grade. So it happens. So don't be too obsessed with this chart and where everything falls. Each child is different. And if you're working with this in an elementary situation, it can still be used as an elementary situation. And in my videos, I'll show you, or I'll tell you a little bit more about how you might use this differently if you're in the first grade, second grade, or third grade environments. So anyways, that's all I have for this introduction. And now I'm going to put together all the videos. So I will make sure and put timestamps in the description down below this video. So that way, if you want to skip back and forth to certain operations, just look at those timestamps and you can skip to the point that you are interested in. So when I get to the stamp game, I'm gonna start by showing them the stamps, and I might say to them, what does that say? And since they've worked with the decimal system, they'll say 1. What about that? What does that say? 10. And I'll ask them, how many zeros does 10 have? 1 0. Same thing for 100. What does this say? 100. How many zeros does it have? 2. And what does this say? 1000. How many zeros does it have? 1, 2, 3. 3 zeros. The reason why we do this is because this is part of the decimal system in the AMI album, and we do really want the child to understand the placement of the 0 and how that affects each category in the decimal system. So it's good to go through those reminders and just help the child remember how many zeros are in each category. So the next thing I might do is give the child a 3-period lesson just to make sure they've solidified what category each one is. And I might say, move the unit over here. Move 100 right here. Pick up the 10. Put the 10 right here. Move 1000 over to this side. And so we'll play that 3-period lesson game where I just have the child manipulate it as I ask them to do different things with the different parts, different numbers, just to make sure they really do understand what a unit is, 10, 100, and 1000. After that, once the child really understands how to do or knows how to identify each stamp, what I'm going to do next is simply show them how to build numbers. And I'm going to start very slowly. So if your child is using this outside of a Montessori classroom, just start with 1 category at a time and ask them to build you 5 units or 5 ones if you prefer to use the word ones. 1, 2, 3, 4, 5. So once the child can do that, they can build 1 category. I always have a ruler on hand because I really like to straighten it out. Children usually love this in the 0 to 6 environment because they enjoy the sense of order. Order is one of the sensitive periods for the 0 to 6 age group. So always have a ruler nearby for the stamp game. I think it really helps. So you can ask them to build numbers in 1 category at a time. So we've built 1, 2, 3, 4, 5 units. And then you can also start doing 2 categories. So if the child can easily build numbers in each category, you can go ahead and start combining categories, such as, can you build 1,300? Okay, let's build 1,300. 1, 2, 3. So 1,300. Let's straighten that out with our ruler. And once the child is working easily with 2 categories, let's go ahead and put on a 3rd category. Doesn't matter which ones you do, just limit it to 3 categories. So for instance, you might ask the child to build you 321. Can you build me 321? 100, 200, 300, 20. 20 is 2 tens, 1 10. 2 tens, and 1 unit. Again, if they're a little crooked, just come along, straighten it out, make sure they're all there. And also, we want to line it up with the categories. This is kind of like our control of error up here as to where the stamps go. So keep in mind the layout of where you're going to ask the child to lay out the numbers. So once we start working comfortably with 3 categories, go ahead and work with all 4 categories, such as, can you build me 1,321? And if the child is building numbers comfortably with all 4 categories, it's time to start adding in the paper. Now, when the child has worked with the golden bead system, we've already given the definition for what each operation is. So for instance, when I do addition with the golden bead system, I've already given the definition in the golden beads by saying addition is when we have a smaller number and we join together another smaller number to create a bigger number. So when we start getting towards addition with the stamp game, we're going to remind the child what the definition of addition is. And every single operation that we introduce with the stamp game, we want to go back, do what's familiar, and make sure the child understands what the definition is for each category, because sometimes they forget, right? So let's start introducing the paper. Put that away, and I'm going to write a number. What does that number say? 2,431. So that's the number I'm going to have the child build. So let's go through this. I'll keep this right here so you can see it as I go through it. How many units do we have? We have 1 unit. Okay, how many tens are there? 3 tens, 1 10, 2 tens, 3 tens. And what do we call 3 tens? 30. It's always good to remind the child the language of the tens. So how many hundreds do we have? We have 400. So let's count. 1. Make sure that your numbers are facing the proper way. 1, 2, 3, 4. 400, how many thousands do we have? 1,000, 2,000. All right, so we've built our first number. We can take our ruler, straighten out if we want to, right? Now, when we're working with the stamp game and the child is starting to comfortably work with you writing a number and then building it, we can start getting into addition. In the stamp game, there's something special that happens in the stamp game that we did not do with the golden beads, and that is we're going to give the language for the operation. So the child already knows the definition, what is addition. Now we're going to put down the parts of addition. So I might say to the child, see this first number right here? That's our first addend, this top number. It's called an addend. Now I'm going to build the second number. I'm going to write down the second number. Say 1,224. And the second number, that's called our second addend. So we have our addend and our addend. These are our 2 smaller numbers we're going to join together. And what's that called when we have 2 smaller numbers that we join together to make a bigger number? It's called addition. And the sign for addition is right here. And when we give the answer, that's called our sum. So let's build our second number. And this is also where we're going to start using this ruler to help differentiate between our first addend and our second addend. So our second addend right here, we're going to build 4 units. 1, 2, 3, 4. And we're going to build 2 tens. 1 10, 2 tens. What is 2 tens called? 20. We're also going to build 200. 1, 2. And how many thousands? It's just 1,000. Now what is addition? Taking our 2 smaller numbers and joining them together to make a bigger number. So let's take out this ruler here. And this is the really fun part of joining them together, because this is addition. We got to join them together. Look at that. We joined our first addend with our second addend. Let's count our answers and see what it is. 1, 2, 3, 4, 5 units. We're going to write 5 units right here. 5. Let's count our tens. 1, 2, 3, 4, 5 tens. 5 tens is 50. Let's count 100. 1, 2, 3, 4, 5, 6. 6. and how many thousands? 1, 2, 3. So our answer, that's called our sum, is 3,655. Now, if your child is practicing static addition and that gets too easy, we have to switch to dynamic addition. Your child, if they've been following along with the golden beads through a Montessori classroom, should have already been introduced to the dynamic addition principle with the golden beads. However, if not, if you're doing this at home and you're getting this and you've skipped the golden bead system, we have to, when we approach dynamic addition, we really want to make sure and solidify that idea of exchanging. So let me show you what that looks like with the stamp game. I'm going to use our sum as our first add-in, just to make it a little easier. So let's do 3,655 for our second problem. So that's now going to become our first add-in. Just picking that number so I don't have to put the stamps back out again. So it's simply for my sake. I'm going to tilt that down just a little bit, make sure we have enough room to see. Now I'm going to write a second number. I'm going to tell the child now, wait for me when you join them together before you write your answer. Wait for me because something different is going to happen this time. So now I'm going to ask the child to put the ruler there, separate their add-ins, and let's build 1,216. So let's build 6 units. 1, 2, 3, 4, 5, 6. Just this down just a touch so you can see what's going on. Okay, 6. Now, how many 10s? 1 10. How many hundreds? 200. And how many thousands? 1,000. Okay. So we have our first add-in, we have our second add-in. Now, in addition, we have to join them together. That part stays the same. Let's join them together. All right, so we've joined together our numbers. Now, something different is going to happen this time. And if the child's worked with the golden beads, you can give them a reminder. Say, when we get to 10, something special happens. Can you remember what that is? Say, we exchange for the next one higher. Okay, so when we get to 10, we have to say stop and exchange for the next one higher. Really emphasize that there is something that's happening that's different. So I'll show you what that looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. What do? Exchange for the next one higher. If we're working with the units, the next one higher is the tens. Right? I want to keep this separate because this 10 is new, right? So these are 10. So because we have 10, we're going to exchange. So these have to go back into the box. So slide them off. This is the fun way to slide them off. Some teachers don't like it. I love it. Why not to have a little fun with it? So I slide them off. That's why you can't have fun with it, because you drop things. I still like doing it the fun way. You'll have to decide. Do you want to do it the fun way or the boring way? I still advocate the fun way. All right. So we slid them off. We put them back in the box. Now, take a look. We exchange for the next one higher, and he's going to join the tens. But first, take a look. How many do we have left over here? What do we have left in our units? We only have 1 because we did some exchanging. Let's count how many 10s we have. 1, 2, 3, 4, 5, 6, 7. And this is where a child who's really gotten into that memorization, that exploration and memorization of math facts, they'll be like, oh, 5 plus 1 is 6. And they won't stop to think, oh, I have to exchange. So you can kind of tell when a child just wants to memorize and not do the work. You can start seeing it on their stamp game paper because they'll just go through and know 5 plus 1 is 6. Be like, oh, wait. Take a look. Something special happened right here that changes that number. So sometimes you might have to tell them, go back, take a look. Something special happened. Let's think about it. Now let's count over here in our hundreds. 1, 2, 3, 4, 5, 6, 7, 8. And over here in our thousands. 1, 2, 3, 4. All right, so let's tell the story of addition for this one. We started out with 3,655 as our first add-in. We joined 1,216 for our second add-in. And when we put those two together, we made a bigger number, and that bigger number is 4,871. That's our answer, and the answer is what we call the sum. What is subtraction? And in Montessori, we tell the child with the golden bead system what the definition of subtraction is, and that is when we have a larger number and we take away a smaller number to make an even smaller number. So what we're going to do today is we're going to remind the child what is the definition of subtraction, and then because the stamp game is the place where we give language for all the parts of the operation, we're also going to show the child each part of the operation and give the language for it, such as, you see this top number up here? This top number, the one that we build first in subtraction, we call that the minuend. And this number at the bottom, the number we're going to take away in subtraction, we call that the subtrahend. And the empty boxes right here, that's where we're going to put our answer. And in subtraction, we call the answer the difference. We're also going to introduce the child to the symbol for subtraction so that they can identify the symbol for subtraction as well. So that's what that sign looks like when we're doing subtraction. That's what we're going to use, the subtraction sign. So I've already set up our first part of our subtraction problem for today. So I've set up our minuend. And here we have our minuend, and now we have to do our subtrahend. So our subtrahend is what we're taking away. Let's take a look. How many units are we going to take away here? We're going to take away 2 units. So let's do that. 1, 2. Our minuend, our subtrahend. What are we going to do with these 2 units now that we've taken them away? We're going to put them back in the box. So our top number is 3 tens. And how many tens are we going to take away? 1. Again, you can see the minuend, subtrahend. We're going to take it away. And of course, our answer is right here. There's our difference. And now let's move on to our hundreds. We have 700. How many are we going to take away? We're going to take away 5. 1, 2, 3, 4, 5. So we've taken away 500. Minuend, subtrahend. Take it away. And now we have our difference. What's our difference? 2. Let's move on to our thousands. We've got 6,000. How many are we going to take away? 2. All right, let's take a look at what our answer is. And what do we call the answer? The difference. In subtraction, the answer is called the difference. So what's our difference in units? 2. What about our tens? 2 tens, 200, 1, 2, 3, 4,000. So what's the answer of the difference? Let's tell the whole story this time. Let's tell the whole story. We started out with 6,734. We took away 2,512. And when we did that, our answer is 4,222. That's the difference. Now, that's pretty simple, right? You build your minuend and you take away. That's pretty easy. So now I want to show you how to do dynamic subtraction, because that one gets a little trickier. That one you might have to sit next to your child or your student for a little bit until they get this one. I'm going to fold this over so that we look at the number that we're currently working with and not the number that we've already done. So let's build our minuend, and I'm going to cheat just a little bit. I'm going to use the stamps that are out to build my minuend. How many tens? I've got 2 already. Let's do 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. How many hundreds? We need 400. And how many thousands? We just have one, or what, 5,000. This is why you have to keep track of what you're doing. Sometimes, now, this is actually a good learning moment because sometimes children do that too, right? They look at the wrong one. So sometimes I take that ruler and I cover up the subtrahend because it gets a little confusing if you're looking at the wrong thing, especially when you're like me and you're trying to record something on your phone and do math at the same time. It's not easy. So if your child does have an issue where they're not looking at the right number, try doing what I'm doing right here and just cover the subtrahend up so that they only see the minuend. Okay, so 1, and we got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5. That's the right number. So there we go. Now I can take that off. And I'm going to move this a little bit over here. There we go. And now take a look. We've got 1 and we need to take away 7. Now, before I get into this, remember that the child has already seen subtraction, both static and dynamic, in the golden bead system if you're following along with the Montessori curriculum. If you haven't been following along with the Montessori curriculum and this is your first time doing it, just go slow and just do this over and over again in different categories until your child understands it. It might be a little confusing at first, but again, they've seen exchanging in addition, so now we're moving on to subtraction. And borrowing can be a little bit confusing, but it's going to be the same idea, but in reverse. So take your time, don't go through it quickly, and just emphasize that when we can't do something, we have to go to the next one higher in subtraction, and we have to borrow. So let me show you what that looks like. So the child's going to look at their operation, and I'm going to say, take away 7. Oh no. You just keep on saying, well, we need to take away 7. And the child's going to say, I can't do that. So what are we going to do? Well, we have to borrow from the next one higher. What's the next one higher? In this one, it's 10. So we're going to borrow this. We need to take this 10. And we need to take this 10 and turn it into units. How many units make 10? 10 units. All right, let's get 10 units out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I don't know if you can see it, probably went off the camera. So we have 10 units here, and we are going to trade this 10 for 10 units. So I've made 10 units. I don't need this anymore because I've turned it into units. So we're going to put it back in the box. So now we're ready to connect. Connect it all together. And then you can say, now can we take away 7 units? Let's find out. 1, 2, 3, 4, 5, 6, 7, stop. Did you do it? Yep, we did it. There we go. So we have our answer right here, and now we can move on. And it's okay if you want to write your answer, do each category at a time and write your answer. That's fine. 1, 2, 3, 4 is our answer. The difference, right? And now we're going to move on to our 10s. How many 10s are we going to take away? 3. 1, 2, 3. What's our answer? The difference is 1, 2, 3, 4. And now we're in our hundreds. We have 400 and we're going to take away 2. We took away 2. What's our answer? What's the difference? 2. And now we're in our thousands. We got 5,000. We're going to take away 1. How many's left over? 4, right? So let's tell the story. We started out with our minuend of 5,481. We took away the subtrahend, 1,237. We got our answer, which is the difference, of 4,244. And there you go. That's how you do dynamic subtraction. And right here, I've written down an operation. We'll start with this first one of 1,212 times 3. So like I've stated before in the stamp game, this is in Montessori, this is where we give our language for the operations. So we're going to tell the child that this top number right here, the number we're going to build, that's our multiplicand. And if you're like me, that is a really hard word to say. So I have to practice really hard to say it correctly. So here's our multiplicand. That's going to be the number we build. And then this number is our multiplier, and that tells us how many times we're going to build that top number. And if you are following along with the Montessori curriculum, you know that the child has already experienced multiplication in the golden bead system. But if you're just coming to the stamp game for the first time, you might want to go back and give the child a reminder of what multiplication is, or tell them for the first time what multiplication is. So what is the definition of multiplication? Well, the definition of multiplication is when we have the same number and we join it together 2 or more times. That's multiplication. So we're going to join it together multiple times. And when we do that, we get our answer, which is going to be the product. So when we take a number and we build it multiple times and we join it together, we get our answer, which is the product. And right here, when we want to show a sign for multiplication, we're going to make this symbol right here. And what does it look like? It looks like an X. So that is our sign for multiplication. So we're going to go through that with the child, give a reminder of the definition of multiplication, or give the definition for the first time if you haven't done the golden bead system, and then give the language for the different parts of the multiplication operation. And now I'm going to start showing you what it looks like to actually do the operation. So let's see here. We've got our units. How many units are we going to build? Got 2 units. 1, 2. How many tens? 1 10. How many hundreds? 200. And I like to keep it fairly small for the first multiplication. Multiplication, when you start getting into the really big numbers, sometimes I even have my students work on a rug or on the floor, because those multiplication problems can get very big. If you're joining together, if you're doing dynamic multiplication and you start joining together a lot of numbers, you run out of space on the table. So I often have my students do this one on the floor when it gets a little bit big. If you have a larger table, that might work. And what's our thousands? 1,000. So here we are. We've got, oh, I need to go get my ruler for this. I really like my ruler for this one. All right, got my ruler. So now we've built our number 1 time, but how many times do we have to build it? Let's look at our multiplier. This is going to tell me how many times I have to build this top number. How many times are we going to have to build it? 3 times. So we've built it once. Let's put our ruler here just to divide up our number so that we can see how many times we need to build it. So now we need to build it again. So we're going to do the exact same thing. Let's build it a second time. And again, just keep it really simple for that first problem. I like to use a multiplier of 3 often, because when you do a multiplier of 2, it might look too similar to addition, and I like it to look a little bit different. So a multiplier of 3 is usually a good way to start, in my opinion. Maybe other people have a different opinion, and if you do, please let me know what you like to do for a first multiplication operation when you're introducing it with the stamp game. All right, so we've built it once, we've built it twice. How many times do we have to build it? 3 times. So we have to build it one more time. Let's do that. So I really like using the ruler for this, and I would encourage you to use a ruler, because especially if children have skipped the golden bead system, or if they don't have a really good sense of order, that ruler can help them organize their work. And a lot of the times, if you haven't had the Montessori experience previously, and you don't have that sense of order built up, and you haven't taught them how to organize their work, that ruler can really help them, give them a visual cue of how to organize their work. And organizing your work is a big part of learning. So now, if your child is in the second plane of development, which is ages 6 to 12, they might not have so much of a sense of order. They're not in that sensitive period for order very much anymore. So it might be a little more difficult to get them to organize their work for multiplication. And if you're noticing that, just help them keep going back to organize their work. But it is going to be a little bit more of a struggle, probably for children in the second plane. In the first plane, I would introduce this probably around the age of 5.5. They still kind of have that sense of order. They're still going through that sensitive period for order. And so organizing their work is more important to them. It doesn't happen quite so much in the second plane. So if you're struggling with that, if you have an older child and they're not organizing their work like this, just understand, that's kind of part of the stage that they're in, if they're in that second plane, and just kind of help them organize it. But if they get messed up, if it's not being organized, then they're going to have a really hard time seeing this multiplication, right? You want to show them it's the same number built multiple times. So that organization of work, really emphasize that with the stamp game if you can. Like I said, I know it's a struggle with some children. I know that's hard. Just keep coming back to that. Keep encouraging them to be patient with themselves, be patient with the material, and spend time building that work in an organized manner. Because organizing your work, no matter what age you are, even if you're in college, being able to organize your work, especially for students who are dyslexic, figuring out how to organize your work is a life skill. So this is a great place to start with getting that understanding of organizing your work. So now that we built it 3 times, what's the next part of multiplication? We have to join it together. Now, this should look familiar to the child, right? We're going to start joining it together. What does this look like? Well, it looks like addition, doesn't it? Because now we're going to join it together, and this part should be very familiar. You can straighten this out. If you're a primary teacher, you're probably still stuck in that sense of order period like me, and you like it nice and straight. If you're a second plane of development teacher, you probably maybe not care so much if it's straight or not so much. They tend to say that whatever age group you get trained in, that's kind of where you function as a person. So if you're a primary teacher like me, you do tend to really like that sense of order. And maybe if you're trained in the second plane of development in Montessori, maybe you don't like a sense of order. All right, so let's get back to finding the answer, which we call the product in multiplication. So let's count here. 1, 2, 3, 4, 5, 6. 1, 2, 3 tens. 3 tens is what? How else do we say that? 3 tens is 30. If your child is still having trouble figuring out the language of the tens, I'll try to sing it for you today. There's a little song, but I have to admit, I still have a little bit of a sinus infection. It might sound really silly, but there is a song you can sing. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There's my sad singing for you today. I don't have a voice. I'm very sorry I subjected you to that. But there are little songs you can sing. Try to get them to do the language of the tens. It's really easy to count 1 10, 2 tens, 3 tens. But by the time we get to the stamp game, they really should be using the language for the tens. So 3 tens is 30. Now 1, 2, 3, 4, 5, 6. 600. How many thousands? 3,000. So let's tell our story of multiplication. We started out with 1,212. We multiplied it by 3, and we came up with the answer, which we call the product, which is 3,636. So that's pretty easy, right? By this point in time, it looks just like addition when we get to this point. Now, if you want to do
dynamic multiplication, it really works the same way as addition. It's just that you're joining the same number together multiple times. And I'll show you how that looks just in case you've forgotten what dynamic addition looks good like with this, because it's going to operate in a similar manner, right? So we've got 300. And of course, we will have done both static and dynamic addition before we get to multiplication. So we've got 2,314. And I want to join it together. Again, I'm going to work with this multiplier of 3, just because I feel like it gives a good visual as a starting number. Now, I wouldn't just go to dynamic multiplication. The child, and I probably didn't state this in my other videos, don't go straight to dynamic. Take your time with static. Go through it, make sure the child has mastered it. You'll know when they're getting bored, when it's too easy. A lot of the times when they start getting to the stamp game, if you introduce it later and they're not really into this concrete work anymore, like if you have a child in the 6 to 12 age group and they're using the stamp game as a remedial work, just anticipate the fact that they're not going to want to use materials. They're going to want to do it all in their head. And the stamp game is really just a way, if they're an older child, I would use the stamp game as a way for them to check their work. It'd be more of a control of error in that sense. But if they're a child that's still in that first plane around the age of 5.5, when you introduce this, they're really going to be interested in working with the stamps. They're going to be interested in that concrete process and that visualization of what multiplication is. So they're going to be absorbing this whole process. It's not going to feel the same as a child in the second plane, but still take the time and make sure they're understanding the process. And if you're wondering, how does the child check his work? How does he know if he's done this correctly? We don't have a control of error outside of the process in the stamp game. So when we're looking at whether or not the child is doing it right, it comes down to you observing whether or not the child is doing it right. And if they come up and they show you their paper and they're like, did I do it right? I'm not going to send them to a finger chart type of an answer system. Because if you go and look at the addition strip board, we have a control chart for them to go and check their answers. There is no control chart for this. You're simply going to observe, did they do the process correctly? Are they getting the answer? If they're not getting the answer right, where is it that they're getting confused? And usually it's here in dynamic where they have to exchange, and they're missing that exchange. So just go through, observe where they're making a mistake. If they're making a mistake somewhere, don't correct them necessarily in that moment. What I would do is either give a lesson to another child and have them observe going through that presentation one more time, and then kind of showing them the process. Because what's important here is the process. If they're making a simple mistake somewhere in the answer, but they're doing the process correctly, then you know you're on the right track. So we're looking at process and not necessarily the answer in the stamp game. So we're not correcting the answer here. We're looking at process, and that's what this is all about. So let me show you what dynamic looks like. And again, we're going to have the child work with static for a long time until we know they've really solidified the process. And if they've solidified the process, most likely they have the right answers. But you might still see a mistake once in a while, and mistakes happen. What we want is the process. That's what's important. So we're going to build for how many times? We're going to build it 3 times. So we built it once. Let's build it a second time. 1, 2, 3, 4. Let's get 2 more. And how many 10s? 1 10. How many hundreds? We've got 300. 1, 2, 3. And then 2,000. So we've got that. We built it once, we built it twice. Now we have to build it a 3rd time. It might go off the screen a little bit. I'll try to scooch it up so you can see it. So again, 4 units. 1, 2, 3, 4. And like I said, it starts getting very long, doesn't it? So that's why I don't hesitate to, if you're working on the floor, try to, maybe if you have a really large board they can work on, to give them a little bit more of a solid workspace. Some rooms have really big pieces of board that the children can get out and work on. And I also, with multiplication, I can, if you're doing an older age group, like in elementary, I've had some of my elementary students work together in groups. So one person will build the first number, second number, the third number. So if you have 3 kids, they can each build a number, and you can still get that group lesson in if you're doing an older group, because second plane children really like working in groups. So this is possible to do this as a group lesson. It's always a little tricky, but I would say if you're in elementary, most likely you're going to need to start presenting things in a group setting. That social aspect is really important in the 6 to 12 age group. So don't be afraid, even though in primary this is an individual work, this is a one-on-one work. But in elementary, if you're doing remedial work with this, you might have to change it up a little bit. Now, I'm not trained in the second plane of development, but I've worked in an elementary room and I've done that. It's worked well for me. You might, if you're trained in the second plane of development, maybe comment below if you have something to add to that comment or if you disagree, but that would be my suggestion. If you have an opportunity to work in a group, do it. All right, so again, we're doing dynamic multiplication, which means we're going to exchange. What happens when we get to 10? Something special happens. What's that? We stop and exchange for the next one higher. So let's count and see how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. Exchange for one higher. And when we exchange, these go back into the box. All right. What's our answer in the units? 2. How many 10s do we have now? 1, 2, 3, 4. How many hundreds? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. So close, but we didn't have to exchange on that one. 9. I wrote it in the wrong box. This is what happens when you try to look at your camera instead of your paper. 9. And I have a nice big brace over my camera, so I can't actually really see what's going on there. 9. There we go. Wouldn't be a video by me if I didn't at least make one mistake. 1, 2, 3, 4, 5, 6. Teachable moment, right? So let's tell our story. We started out with 2,314. We multiplied it by 3. And our answer, which we call the product, is 6,942. And there you go. You have just seen static and dynamic multiplication. If you liked this, go ahead and give this video a thumbs up. Also, what really helps is if you comment and you share this video with others. That really helps my channel. And of course, what helps my channel even more is subscribing so you can stay tuned to more videos. So if you like what I'm doing, subscribe and share it with others, and I will see you in the next video. If you find that your student starts writing their answers in these boxes up here instead of down here, and you're using this type of paper, if you're not using this type of paper, it might not be a big deal. But sometimes if they're making mistakes and you're noticing it a lot, just have them block out this area right here. Gives them a visual clue that we're not using those boxes, and then they can go ahead and write their answer in the boxes below.
So this is division. We finally made it, and I love division. It's one of my favorite lessons to give in the math section of the Montessori classroom for the primary age group. And let me move on to the next slide. And the reason why I'm showing you these slides first before just jumping right into giving you a presentation of the stamp game like I did in my other videos is because division works different in a lot of different ways. And I figured there were enough things that were different. I wanted to go over those first so that I didn't forget any important points because it does work differently. So I'm going to go through these slides first, and then I'm going to jump into giving you a presentation. So if you don't want to listen to any of this extra stuff, just skip ahead, and there is an actual presentation in this video. It's not just me reading slides to you. But first, I really want to give you the background information on division and tell you about what's different so that you have that information up front and that you can both hear it and see it. So first of all, the prerequisites. What has the child done before they get to division with the stamp game? And of course, the first thing to say is they've done addition, subtraction, and multiplication with the stamp game. Now, before they do division with the stamp game, they've done division with another material in the classroom. What material is that? That is the golden bead system, and they have done both static and dynamic division, short division, with the golden beads around the age of 4. And if you're thinking, Teresa, you do division with 4-year-olds in your classroom? Yes, I do division with my 4-year-olds in my classroom. Sometimes they're 5 when they start, sometimes they're 4. And if you're wondering how that works, it works beautifully. Not only does it work beautifully, it tends to be the lesson that all my students really want. So they wait for the moment they get to do division, because there's something special about division that a 4-year-old or a 5-year-old is very interested in. And that is the one thing that makes division different. What is division? Well, it's sharing equally. And if you know anything about 4 and 5-year-olds, sharing equally, they are very invested in this concept. So it's all about presentation, right? It's all about how you present it. So when we go through the golden bead system, I have a large amount of golden beads, and I tell them, well, I have all these golden beads, and I have 3 students here. I need to share equally with them. So then I show them how to share equally with the golden beads. And so the 4-year-olds absolutely love this. The 3-year-olds love this. And in fact, a lot of the times the younger children, the 3 younger 4-year-olds will say, oh, when can I do division? I want to do division. And I say, oh my goodness, I can't wait to show you division. But first, you have to work on addition, subtraction, and multiplication. And then once you work on all of those, then I get to show you division. Or if it's an even younger child that needs a little bit of motivation with numbers 1 through 10, I'll say, oh, I can't wait to show you division. But first, what comes first? Let's go to our shelf and let's look at the journey to division, and I'll show them all the lessons that they need to work through to get the division lesson. And this helps them get a little bit of motivation. So when I do the division lesson with golden beads, I like to have 3 students, and I get all these golden beads and I share them equally. And when I do that, I give them the definition of division. And basically, I've already given you the definition of division, and that is when we have a large number and we want to share it equally. Now, when we give this definition of division, we also have to give these 3 rules before we start division so that we can share equally, right? We have to have 3 rules. The first rule of division is we have to start with the largest category, which on the stamp game is going to be the left side. Now, we've been working on the right side of the stamp game, right? Right to left. Not so with division. Division's going to be different. We're going to start with the largest category, and we're going to work our way to the smallest. So that's rule number 1. The second rule is we have to share equally. And this is where you get their attention right here. You got to share equally. I would even say that if I was to say there's a point of interest in division, that would be it, sharing equally. So we have to share equally is rule number 2. And the third rule that I introduce them to when they're younger with the golden bead system is the answer is what one person gets. Because remember, I've got all these beautiful golden beads and I'm sharing them with my students. But when it comes to doing the operation, the actual answer is only what one person gets, not what all of them combined are, right? Because if we go back to combining them all together, we've got our dividend again, and that's not the answer. That's not the quotient, right? So that's where the child has already been. And now we're moving on to what they're actually going to learn next, and that is what they're doing during the stamp game. Now, as I've stated before, the stamp game is the place where we give a lot of language for the operation. So we orient them to the division with the stamp game with our language, and then showing them how to write it. So the language for the stamp game, our large number that we want to share equally, our large number is our dividend. So we're going to point that out to the child. And then we're going to show them the division sign. So we're going to show them what that looks like, which means that we're writing it on regular paper and we're not doing the stamp game paper this time because we want to show the division sign, the symbol for it. And then we're going to show them what the divisor is. And if you're doing the golden bead system, what is the divisor? Well, the divisor would be the students that you're sharing the golden beads with. But in the stamp game, it's going to be the Skittles. And then, of course, our answer is the quotient, what one person has. But in the stamp game, it's going to be what one Skittle has. And I'll show you what that looks like in just a few minutes. So anyways, like I said before, we don't start out using the stamp game paper for division. Now, there is a variation of this where you can do that. I would encourage you to write it either on graph paper or blank paper, because really, when it comes to doing the stamp game and doing that orientation and showing them how to do the language for division, I like showing the division sign, and that symbol I like writing out. So on one line, and I'll show you what that looks like further in the video. So if you're not understanding what I'm saying, don't worry about it. You're going to see it here in a few minutes. So anyways, when we get into division, we start setting up our operation. The stamps are the dividend. The Skittles are going to be the divisors. And we're going to show the discs as well. There's little discs inside the box, and those are to represent 0. So when you see 0 in an equation, that's what the discs are for. And then, of course, we're also going to show the child eventually how to do a remainder with the stamp game. And when we're doing the division with a remainder, I'm going to show them, first of all, how to write the remainder. But also, this is a good time for you to introduce to the child that when they have a remainder, it has to be smaller than the divisor. So the divisor's 3, you have to have a remainder less than 3, right? So that's another thing that you can introduce with the stamp game with division. And today I'm just going to go and show you a presentation, a very shorter presentation. I'm not going to go through all of the stamp game lessons possible. I just want to give you a taste today, and I think that'll be more than enough to get you started. So today we're going to go over short division, and that's both static and dynamic. Today I'm going to show you how to do the remainder as well. If that's not enough for you, I understand. I have more lessons I can give on division using the stamp game. I can show you long division. I can show you 0 in the divisor. I can show you 0 in the divisor and the dividend in the units only. And then I can also show you group division. I might actually do a longer video for group division, because you start out with the golden beads and then you work into the stamp game. So that's a little bit longer. But those I'm not going to do today. I'm just going to do static and dynamic short division. And that'll be the one you typically use, right? However, long division's not so bad. It's kind of fun as well. So I will be sure to make a video on that. Now, to finish up with our slides at this point, before I jump into the video presentation, I just want to remind you that the control of error in the stamp game in these operations is in the process, not the result. So if you have a child that's not getting the right answer, just make a mental note of it. Observe it. You might need to come back and represent something to the child, but we're not interested in correcting the child at this point. We're not giving them a control of error to go check their answers. We're interested in the process, not the result. And that's what this is all about. Now, this is, of course, for 3 to 6-year-old child. If you have a little bit of an older child, a child that's in that what we call the second plane of development, a child that's more in the elementary level, you might want to give them the opportunity to correct their work. It's always better if they can get the answer from a source outside of the adult. So if you have a way for them to correct their answer, a control of error to help them correct their answer, that would be great. Maybe you want to introduce the calculator at that point in time and say, can I check my answers with a calculator or something like that? So if it's elementary age and they're a little bit older, you might want to start working in a control of error. But if you're in that 3 to 6 age group, not necessary. We're just going to focus on the process. And of course, the purpose. What is the purpose of doing the division with the stamp game? It's to learn division and also to learn how to exchange for the next category lower, which is another difference in the stamp game, right? You got to exchange lower this time. And the target age for this in a Montessori classroom, in an AMI Montessori classroom, about the age of 5. And like I said, children love sharing equally. They love division. Don't underestimate them. Now use this as a motivation too. Say, oh, I can't wait to show you division, but you got to do addition, or you got to do subtraction, or we got to get through multiplication first. And so give them some motivation to get to division because they're going to be intrigued with the materials. So give them a little motivation saying, I can't wait to show you this lesson, but you got to get through this other stuff first. So anyways, that's all I have for you in this part of the video, but I'm going to stop right now and I'm going to cut over to giving you the presentation of what it actually looks like to give a lesson on division with the stamp game.
All right, so here we are with the stamp game and division. And as usual, let's go through our orientation to where we are with this operation. So first thing I'm going to show them is our first number, the 9,639. That is our dividend. Here is our divisor sign, or our division sign, and here is our divisor. What is our divisor here? 3. 3 what? 3 units. That's very important. So remember, this is 3 units. And here's our equal sign. This will be the operation we do next. I'm only going to do static and dynamic short division today. If you are really desperate for a long division lesson, let me know below and I'll try to get on that. But I figured for right now, let's just focus on really simple division. So let's stick with the short division, and then I'll make a separate video for long division because sometimes all those different lessons can get a little bit tricky. Okay, so we've got our equation right here. You've learned what each part of the equation is. I'm going to set that down. And now we're going to take a look at the stamp game. I've already set up our first number, our dividend. So I've set up our dividend. These are our stamps, our dividend. And now, if you can see here inside the box, there's these other things that the child has been waiting to work with for several operations now. We have the Skittles and we have the discs. And as you can see, there are different colors, and you can probably guess why they're different colors. So these are called Skittles, and the Skittles are actually our divisors. Now, our divisor in this problem is 3. 3 what? 3 units. So it's not tens, because if they were tens, we would have to use the blue, right? And if they were hundreds, we'd have to use the red. But they're not tens or hundreds, they're just units. So how many units? 1, 2, 3. So right there, we're going to get our divisors out. Those are 3 units. Let me put that down. So we've got our 3 Skittles for our 3 units that we're going to use with our divisor. Give them a little space between each one. And you notice I set up the dividend down low. A lot of the times we start out at the very top of the box, but not with division. Division, we really want to put that dividend down below. Now, because the child has worked with the golden bead system, they already understand the definition of division. What is the definition? Well, the definition is when we have a large number and we want to share equally. So what are the rules? The rules of division are, there are 3 of them. We have to start with our largest category. We have to share equally. And the answer is what one person or one Skittle has. So there's our definition. There are our rules for division. There's the language for division. Now let's actually share equally, starting with the largest category. Here we go. And this next part is very important. When I went to training, if you're going to do division, you've got to say 1 for you, 1 for you, and 1 for you. So practice that at home. 1 for you, 1 for you, 1 for you. Okay, we shared equally, but we have more. We can keep going, right? All right, let's keep going. 1 for you, 1 for you, 1 for you. Oh, we can keep going. 1 for you, 1 for you, 1 for you. You have to say 1 for you. It's a rule. If you don't like it, that's too bad. You got to say it. Now we're out of thousands. So what do we do next? We go to the next one lower. 1 for you. 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 Oh, we're out of the hundreds. 1 for you. 1 for you. 1 for you. Now we've made it to the units. 1 for you. 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 Look at that. We shared equally. Now the answer is what one person or one Skittle has. So let's write our answer. How many thousands does one Skittle have? 1,000, 2,000, 3,000. So we have 3. How many hundreds? 2. How many tens? Just 1. And how many units? 3. So we started out with 9,639 and we divided it by 3, and our answer, or our quotient, is 3,213. Now we know that in division, sometimes things don't divide equally. So let's put this back. I'm going to use the same number again, but I'm going to change our divisors. No, actually, I'm keeping the divisor the same. I'm going to change our dividend just a little bit. And this time, instead of 3 tens, we're going to do 5 tens. Here we go. I'll set that up in just a second. I'll get my ruler out and I'll make it beautiful in just a second. So I'm going to keep the divisor the same and just change the tens in the dividend. Let's make this beautiful. Isn't that satisfying? If it's not satisfying, you're probably an elementary teacher, right? Not a primary teacher. So we say, right? Maybe that's not true. I don't know. I'll try not to spend all my time playing with the stamps and straightening them. But it's really driving me nuts that they're not quite even. I'm going to go ahead anyways for the sake of time. So now, this time we got to share evenly again, right? And we're going to get to this lesson. This lesson would come after the child has already practiced that static division over and over again and have a really good feel for it. So don't move on until the child has already done the other lesson proficiently. We don't want to introduce something new until they've mastered the thing that they're working on. So 1 for you, got to say it every time. 1 for you, 1 for you, 1 for you, 1 for you, 1 for you. And this is the one where the child really does need to organize their work. This is hard for some children with disabilities, so they might need a little bit of help, right? 1 for you, 1 for you, 1 for you. 1 for you, 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 1 for you. Oh, stop. Can we share the tens equally? No, we can't. I'm going to move the units out of the way just a little bit because this is going to get a little messy. Okay. So we have these 2 tens that don't share equally, right? Well, we have to share equally. I mean, that's what division's all about. And how are we going to do that if we can't share it equally? All right, can make a little bit of room here. What do we have to do? We have to exchange, right? So how many units does it take to make 10? 10. So let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that's 10. So we have 10 here. I have the 10, right? But it can't be shared equally, so I have to exchange it. I have my 10 units. I have this that can go back in. Now let's just double check as we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. And yes, it's a little messy. I'm going to keep it messy for this time because I'm trying to keep my videos down a little bit in time so it's not quite so long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I've got 10 here. What do we do with that one? Well, it goes back into the box, right? So let's count again. I'll do it to this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here I would just reorient any that might be upside down or sideways, because orientation is really important, especially if you have a child that's really struggling with dyslexia, or a child with ADHD that's really struggling with organizing their work. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so our original row is right here. It's got 9, and then we have 10 and 10. And this is where it kind of, your space gets a little bit tricky, but I didn't want to put this one over here because I was running out of space. So we can always move it down, but just keep in mind the space that you need to work with it. And then you can also do one at a time too. You can exchange 1 10, share equally, exchange the next 10, share that one equally, and then move on to that last row. So that's a different way of doing it. If you don't like the way I did it, there is another option. So now we have to start sharing equally again, right? So 1 for you, 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 1 for you. I'm going to go over to the side. 1 for you, 1 for you. If they start getting lost in their work, just count. I have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, good. We're still even on the ones. That means we're in the right spot. So if you start to see that it's uneven, just remind them they can count each one. 1 for you, 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 1 for you. Sometimes we need to push them up a little bit. So we go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? We're even. So that means we can keep going. 1 for you, 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 1 for you. Can we share these equally? We cannot. And this is where we want to show them how to do a remainder. But first, we're going to write our number like we usually do. And usually I'd keep a red pencil on hand to write the remainder, but I don't have a red pencil on me right now. So let's count our answer. 1, 2, 3. 3,000. 1, 2, 200. 110. How many units? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that was close, right? Just 9. Let me go see if I can grab a red pencil. And I have these two at the very end that can't be shared equally. And so what I call those is a remainder. So this is how we write the remainder. We're going to use the letter R for remainder. R, yep. And how many? 2. So our answer is 3,219 with a remainder of 2. And that's how we would show that.
Today, I am going to prepare you for long division on the stamped game. But before I can show you that, I need to take a step back and show you a little bit more of where we start with long division. Now, this lesson is given about at the age of 5.5 to 6 years old. And before we go into long division with the stamp game, we actually have to go back to the golden beads. And I have to show you that first we introduce long division with the golden beads before switching to the stamp game. So again, this will be something we go back to. And right now I just have a diagram from my album. When I go through the collective exercises, I'll do this more in detail. Right now I'm waiting for my golden bead material to arrive. I don't have all of it, and that's why I've held off on showing you this, but also this gets a little bit complicated to film. So that's the other problem with filming this. So I'm going to try and talk you through just a little bit of what this experience looks like before we jump back into the stamp game. So with the golden bead material, we would go ahead and show long division, and we would show it by gathering our dividend, which is the big number, right? The 2,832. We're going to get all of that in beads. We're going to get 2 units, 3 tens, 800, 2,000. And what is division? Division is sharing equally. What are the rules? We start with the largest. We share equally, and the answer is what one person has. Now, we've done division, both static and dynamic, with short division, and we've done that in the stamp game, and the child has experienced it also with the golden bead system around the ages of 4 to 5 years old. So now that they've had that experience in division, they can go on to long division. And so we come back to the golden bead system, we gather golden beads, we get this number, and it's the large number 2,832. 2,832. Let me say it correctly, right? So we get that number, we build it in the cards, and we have it in the golden beads. We have our unit beads, our 10 bars, our 100 squares, and of course, we'll have our 1,000 cubes, and would have 2,000. And so this is just a picture of the final step. So if you're looking a little confused, it's because this is what it looks like when it's all finished. So let me backtrack back to the beginning of how we would present this. So if I'm going to do the equation 2,832, I'm having a hard time saying correctly today. Let me try this again. So if I have the number 2,832 and I want to divide it by 12 and I want to give that lesson to some of my students, I'm going to invite 3 students. I'm going to invite 3 students, and one of those students, I'm going to say, you know what? I need you to go find 9 friends. And they go around the room, they invite 9 friends. Now, sometimes this is inconvenient. So sometimes I just ask them to think of their friends and I write it down on a piece of paper because sometimes that can be distracting in the classroom. In some classrooms don't have a lot of children in it. If you're just starting a classroom, you might not have 9 children, or if you're homeschooling, you might not have 9 children in the classroom to use. So sometimes I just list their names down on a piece of paper as they tell it to me. So 9 friends plus the 1 child is 10, right? Then I have my 2 other students. So I have 3 students total. And I say, okay, we're going to divide this time. We're going to do division. But this time it's going to be different because I'm going to have one of you collecting for you and 9 friends. That's 10 people. You're going to collect for 10 people. And then the other 2 are just going to collect for 1 person. And so we have to have this new rule. When we share equally, the person that's collecting for 10 people gets 10 more than the other people. So we call this division with bows because when I invite the children over and I tell them how many people they're going to be collecting for, they get different bows. So the children who are collecting for just 1 person gets a green bow, and the child that's collecting for 10 people gets a blue bow. Now, where have we seen this before? In the stamp game, you know that the units are green and you know that the 10s are blue. So the child with a blue bow is collecting for 10. And so our new rule now is what the child with the blue bow receives, they're going to collect for 10 people. And so they're going to get 10 times more. And this is going to be the experience of how they experience this for the first time before we move on to the stamp game. So we usually show this once, maybe twice, and then we jump back into the stamp game for long division with the stamp game. So I just kind of wanted to show you this really quick. So when we divide it up, the answer, we have to remind the child, is still what 1 person gets, but it's 1 person with a green bow or 1 person with the unit, right? the unit representation. That's the answer. So then we can go, when the child has the blue bow, their answer is going to look different. And so then when their answer looks different, we break it down into the smaller categories in all the units. We get 10 units out at the very end, and we show the child with the blue bow that really you have the exact same answer as everyone else if you break it down into units. But because we put it together in the tens, it looks a little bit different. So we do show that very concrete example of how the child with the blue bow really has the exact same answer. It's just that we are putting it all together. So we do break it down once, but then when we get to the stamp game, we don't break it down again. We just keep it there, and we remind the child that the answer is what one person has, or one Skittle. And when it's with Skittles, we say one green Skittle. So that's how we introduce it. I'm going to stop with showing you this and actually now switch over to doing the stamp game with long division. So here we go.
All right, so here we are. I'm ready to do some long division, and I have it set up here. Our operation is going to be 1,625 divided by 13. And again, we can always do this reminder at the beginning that our divisor here is 13. So how many units does it take? 1, 2, 3 units. How many tens? 1 10. And because the child has already had the experience with the golden beads of doing long division, you can remind them, just remember that the blue Skittle is going to get 10 times more than the green. So let's repeat the rules for division. We start with our largest number. We share equally. And the answer is what one person or one unit Skittle gets. And of course, we have to add the rule that the blue Skittle gets 10 times more than the green Skittle. So what does that look like? 1 for you, 1 for you, 1 for you, 1 for you. So this one's getting 10 times more. Okay, so we're out of our thousands. Let's move on. 1 for you, 1 for you, 1 for you. Oh dear. We can't share equally. What are we going to do? We're going to have to exchange, aren't we? Let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we've got 10 here. Put that one back. Straighten these out so they're in the correct order. All right, I got it. And 1 for you. Is that better? Let's try it again. 1 for you, 1 for you, 1 for you, 1 for you. Now, these have 10 times more than the green, right? So we're still doing all right. 1 for you, 1 for you, 1 for you, 1 for you. That gets 10 times more than that one. 1 for you, 1 for you, 1 for you. Uh-oh. We need to take one of these. We need to exchange it, don't we? All right, let's put it right there for a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, put those in order. Make sure we have 10 before we start sharing, because this is where all the little mistakes happen, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we can put this one back. And 1 for you. 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 Beautiful, huh? And if you want to be really OCD and go ahead and straighten it up, feel free, but that would take too much time for me, so I'm going to leave them just a little bit messy, if you don't mind. So our answer is what one person or what one unit scale has. So let's see what 1 has. So we've got how many hundreds? 1. How many tens? 2 tens. What do we call 2 tens? What's the language for that? 20. Let's count our units. 1, 2, 3, 4, 5. And there is a very simple long division equation. But I'm going to go on and show you a couple others. So hold on just a second while I reset it, and we'll go to next to long division with 0 in the divisor, and I'll show you what that looks like. All right, so here we are with long division with 0 in the divisor. So right here, we're going to be doing 9,135 divided by 203. And this is where we get to use these discs. Now, because the disc is in the tens position, I'm going to use a blue. So there are different colors. So if it's in the units position, you use a green. If it's in the hundreds position, you use a red disc. So when we're bringing this out, we're going to make sure to tell the child that that means there's nothing there. It's a 0. We can't do anything with it. And if you've been following along with Montessori curriculum, we established this language with the spindle boxes, and we say, what do we do with 0? Nothing. We can't do anything with 0. In fact, we play a little game called the 0 game to emphasize that 0 means we can't do anything with it. So we're just going to be telling the child there's nobody home, we can't do anything with it. So we're not going to share anything there, right? But we're still going to follow our rules for 10 times more than the others. So let me show you what that looks like. So we're going to start sharing equally, as we always do with our largest number. 1 for you, 1 for you, 1 for, oh dear, nobody's home. We can't do that. So let's go to here. 1 for you, 1 for you, and 1 for you. Right? That seems pretty simple. 1 for you, 1 for you, 1 for, oh dear, nope, can't do anything there. Oh, can't do anything there. We're going to have to do some exchanging, aren't we? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ready? Let's make it look a little bit beautiful. It doesn't have to be perfect. It can be perfect if you would like it to be perfect, and I'm all right with that. And while it can be a little messy, we want to make sure and organize our work, because an organized work means that we are probably going to catch any little details when there's a mistake. So organizing your work is always a good thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. All right, we can put that away. So now we can share equally. 1 for you, 1 for you, 1 for you, 1 for you, 1 for you. Oh, nobody's home. 1 for you, 1 for you, 1 for you. 1 for you, 1 for you, 1 for you, 1 for you, 1 for you. I'm gonna push these up so we have more space. And let's go back. 1 for, oh, we can't share evenly anymore. So let's start exchanging these. So we gotta exchange this one. Let's count out 10 hundred, 10 of the hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we're ready to keep sharing. Let's go. 1 for you, 1 for you. Oh, nobody's home. 1 for you, 1 for you, 1 for you. There we go. 1 for you, 1 for you, 1. Oh dear, nobody's home. And then 1 for you, 1 for you. We have to exchange. put that right there. Let's get out 10 units. 1, 2, 3, 4, 5. 6, 7, 8, 9. Can we fit our 10th? Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 here. So that means I can put that one back. And 1 for you. Let's keep sharing. 1 for you, 1 for you, 1 for you, 1 for you, 1 for you. I hope you're saying 1 for you at home. 1 for you, 1 for you, 1 for you, 1 for you, 1 for you. 1 for you, 1 for you, 1 for you, 1 for you, 1 for you. This stays empty, right? There's nobody home. So let's count our answer. What's our answer? It's what one person or 1 unit Skittle gets. So let's write our answer. Let's see how many 10s. 1, 2, 3, 4 10s. What's the language for 4 10s? 40. So got our 4 10s. How many units? 1, 2, 3, 4, 5. The answer, the quotient, is 45. So that's how you do long division with 0 in the divisor. Next, I'm going to reset and do 0 in both the dividend and the divisor, so you can see that real quick. So let me reset for that. All right, so here we are with long division with 0 in the divisor and 0 in the dividends, but both in the unit position. So those both will have 0. We're not going to do anything with those. So let me show you what that looks like, because that kind of changes things. And I know some of you are looking at this thinking, well, I already know what to do. But the child doesn't, right? So we are going to give them the full experience of doing this, and then we're going to show them the easy way. So if you've already figured out the easy way, we're going to work towards that, but we're not going to start there. So let's start by sharing equally. 1 for you, 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 1 for you. Nobody's home. All right, let's keep going. All right, 1 for you. Oh, not enough. So let's break it down. Let's put it right there. I'm going to put it over to this side. Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me count them. Make sure it's 10. Make sure it's correct. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, so this 1,000 can go back into the box. So now we can start sharing equally here, right? 1 for you, 1 for you, 1 for you, 1 for you. 10 times less, nothing. We're going to keep going. 1 for you, 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 and we're done, right? Oh, wait a minute. We can't be done because the answer has to be what one person has. So this is what 10 people have. How are we going to figure that out? Let's try this. 200, 200, 30 divided by, what would it be divided by? 10. Let me reset that. Okay, so here we are set up to break it down. I've got 10 units to show you how to break down 230 divided by 10. And If you're noticing this guy looks a little different, it's because my stamp game only comes with 9 Skittles, so I had to go to my second stamp game and get 10 Skittles, because not all stamp games think that we're showing the full entire lesson, but we do, and so we do need 10 and not just 9. So you might have to rig something to find an extra Skittle, maybe buy 2 stamp games. It's always good to have 2. They never seem to give you enough in a stamp game. But let's start sharing equally. Uh-oh, I can't share equally, can I? So I'm going to have to exchange this. All right, it just so happens I pre-prepared this because we're going to be doing a lot of exchanging. So I already have some 10s set out down here. I'm going to move them up and exchange. We'll do a quick exchange, right? So I'm going to put my 10s right here that I just exchanged. And we're going to have a lot. And now, can we share? Oh, we still can't share equally, so we're going to have to exchange this one again. Just so happens I pre-prepared that too. So down at the bottom here, I have 10 10s. So we're already set for exchanging. Now, I think I finally have enough. I have enough. Finally, right? I'm going to move the disc for 0 because we might do some exchanging here that might create it. So here we go. 1 for you, 1 for you, 1 for you, 1 for you. And this is where if you don't organize your work, you might make a mistake, because sometimes it gets hard to see where they go. 1 for you, 1 for you, 1 for you, 1 for you. This is very important. I hope you're saying 1 for you. Sometimes I forget though, so if you forget, I'm not going to be too hard on you. 1 for you. Let's keep going. 1 for you, 1 for you, 1 for you, 1 for you, 1 for you. These are all green, so they have to be equal, right? 1 for you, 1 for you, 1 for you. All right, let's share equally. Oh no, we can't do it. We're gonna have to exchange this one. Just so happens I also pre-prepared 10 units, so I have a whole batch waiting on the sidelines, ready to come in, right? Let me bring them over. Here we go. Got a 10. All right, let's share equally. Oh, we can't share equally with that one either. We're going to have to change that one into 10s too. I just so happen to make a group of 10s, so we're ready to go. And of course, we have to do this one more time because we can't share that one equally either. Here comes another group of 10s. Oh, this is a lot, isn't it? Oh my goodness, look at all these units. They're not organized. It's too messy. And look at, I didn't even pay attention to where I put this. I put this back in the wrong place. It happens. It happens to adults and to students, right? All right, so we got all these units. We have to share them equally. They're not very well organized, but let's go for it. 1 for you, 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 1 for you. Is this your moment of zen, or is this really annoying you? 1 for you, 1 for you, 1 for you, 1 for you. I hope if you're a child, this makes you laugh. 1 for you, 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 and 1 for you. Let's keep going. I got more to go. I got more to share. 1 for you. We got to share equally. 1 for you, 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 1 for you. We did it. We shared equally, didn't we? Okay, so now we're ready to write our answer. 230 divided by 10. 230 divided by 10. 1, 2. 2 10s. What's the language for that? 20. 1, 2, 3 units. So our answer is 23. So for those of you who thought this was just a lot of work, there's an easier way to do this. You are right. This is where we'd go and we show the child that when we have this 0 right here and a 0 right here, we're just going to cross that off. Because it doesn't change the answer, does it? 23 divided by 1 is, it's still 23. So that's how we show the child how to do this one. Now, I have one more division problem for you. Hopefully you can hang on for one more because we're going to do group division next. So let me pause and reset one last time. So our very last division problem, and then we are done with the stamp game, is going to be group division. So we're going to show how division is the opposite of multiplication, which we also do show in the collective exercises with the golden beads, but we're going to show it again here with the stamp game through group division. And we're going to start out with the operation 1776, very good year, divided by 222 equals. So that's what we're set up for, 222. So we've got that right here. So let's start sharing equally. Can we share equally? Nope, I only have 1,000, so I have got to exchange that. It just so happens I prepared some extra 100s in the anticipation of needing them, just to make things a bit quicker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's put that back. We don't need that, right? We exchanged. By now, we're really good at exchanging. Now, I think I'm ready to share equally. Let's see here. Let's do 1 for you, 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 1 for you. Now, yeah, I'm going to try and make these kind of perfect because that's important for group division. 1 for you, 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 1 for you. Oh, look at that. We're going to need to exchange one. I did not pre-prepare this one, so this time we're going to have to do it the hard way. Put that right there so that we remember it goes back in the stamp game. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10. I know you can't see when it gets to the bottom of this. Someday maybe I'll have a better situation and you can see everything. But for today, this is what I have to work with. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10, so I don't need that. Let's put that back. 1 for you. Oh dear. Well, look at that. All sorts of exchanging today. Put that right there. Grab these 10 units. We're going to need them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put this one back. Now we're ready to share equally again. Whew, that was close. All right, 1 for you, 1 for you, 1 for you, 1 for you. I'm going to try and make them lovely, right? Group division is a very beautiful thing to see. All right, 1 for you, 1 for you. I'm going to bring these down just a little bit so we can see better. 1 for you, 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 1 for you. Are you noticing anything about this? 1 for you, 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 1 for you. Now remember, our answer is what one person or one unit Skittle has. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So our answer is 8 units. But this is group division, so there's something else we can show. We can show that these rows are divided into numbers that are equal all the way down, right? Let's see how many times we've made the same number this way. Because if we make a number this way, what is it? 1, 200. 2 tens is 20. 222. How many times did we make 222? We made it 1, 2, 3, 4, 5, 6, 7, 8. We made the number 222 8 times. Now wait a second. I'm using the word times. What are we doing here? So we made the number 222 how many times? 8. And if you do that, it equals this number, 1,776. So now we can see that multiplication is the opposite of division. Cool, huh? Anyways, that's all I have to share with you today. So we got through 1, 2, 3, 4 division problems, 5 if you count that one. That one's kind of 2, and an extra multiplication problem. I think that's probably enough for today. If you like what I'm doing here, please give this a thumbs up, comment below, share with anyone who you think might be interested in this. And as always, if you really like what I'm doing, subscribe to the channel, and I will see you in the next video.